All right. So cosecant of minus pi over 3. And they're saying they want us to use the even odd properties. Do you remember? Do you remember those? Even odd properties? Oh, wait a minute. Okay. So, see if it's working now. There it is. All right. So even odd properties. So we're supposed to use the even odd. What does that mean, the even odd properties? What did we learn last time? Yeah, cosine and his reciprocal secant are even, and sine, his reciprocal cosecant, and tan and his reciprocal cotan are odd. And what does even mean? It means when you plug in a negative, well, rather than write out words, so it means f of negative theta is, it just goes away, right? For even, it just becomes positive. And for odd, when you plug in a negative angle, where does the negative go? To the front, right? So negative to the front for odd, negative vanishes for even. Remember that? Even, odd functions. So cosine is, and his reciprocal are even. Cosecant, that's the reciprocal of sine, that's odd. So where's this negative sign they're plugging in going to go? Is it going to vanish or go to the front? Going to go to the front. So it'll become negative cosecant of regular pi over 3. That's the point of the even odd thing. You either erase the negative sign completely for cosine or secant because they're even, or you move the negative sign to the front for odd functions. Cosecant is an odd function. So the negative goes to the front, and then we just do cosecant of pi over 3. How do we do cosecant of pi over 3? What's pi? 180 degrees. So you make that negative. It's a funny looking negative there. Make that negative cosecant of 180 degrees over 3, which is negative cosecant of 60, huh? So go to the unit circle. Put a 60-degree angle. It'd be right there. Right? 60 degrees is almost to 90, almost straight up. Right? And then you got to find the values. Remember, it's over and up. It's over a small amount. It's up a large amount, isn't it? It's over a little bit, but way up because it's past the halfway point. Right? This would be the halfway right here. So it's past halfway. 60 is more than 45. Right? It's more than halfway to 90. So it's over the small amount. And what are the small? The medium and the large, remember they're root 1, root 2, root 3, all over 2, aren't they? So root 1, root 2, root 3, over 2. So the small is root 1 over 2, or just a half. Notice you don't need that root. Root of 1 is just 1. Half the large is root 3 over 2. So that means this dot right here is over a half up root 3 over 2. And remember, the x value is always the cosine. The y value is always the sine for a point on the unit circle. So what do we do for cosecant? Yeah, it's 1 over the sine, huh? So it's negative 1 over, and what's the sine? Root 3 over 2. So it's negative 1 over root 3 over 2. Grab that root 3 over 2, flip it up. Whenever you have fraction in the bottom of a fraction, flip it up. So it's negative 2 over root 3. Can't, that's the answer, except we can't leave a root in the bottom. Multiply root 3, top and bottom. What do we get? 2 root 3 over plane 3, negative, I should say. That's still on the screen, yeah. So it's negative, I don't know where to stick that negative sign, maybe right here. Negative 2 root 3 over plane 3. And there we go. Questions? Excuse me. Excuse me again. That all good? You guys are looking like, this is easy, Mr. Heron. We've got it. Listen, if I'm reading your faces right, that's good. Yes, good. I knew a couple of you would have it. Yeah, so sine 51 times cosecant 51. I don't know what the sine of 51 is. I have no idea. You'd have to use a calculator. But what's cosecant of any angle? 1 over the sine of that angle, so it cancels, it's 1. Whatever they are, they cancel, huh? So they're just making sure you know that. That's all they're doing. Good there. Somebody saw it and knows the answer already, right? No? Didn't see it. All right. Cosine 386 times secant 26. What is it? It's 1 again. Now why? Why is this one 1? How does Kelton know it's 1? First off, what do you do with this 386? That's a big angle. That's more than a whole circle. So what do you do whenever they've gone more than 360? You just subtract the full circle. They're at 26. Aha. So it's cosine 26 times c. And what's secant? 1 over, it's the reciprocal of cosine, so it's 1. So it's being one step trickier than the last one. Good. For the properties, is that okay if I flash that off? Got that? Too quick, I don't know it either. All right. I don't know. I'll just write it down and see what we can do. Plus. Weird. I don't know. All right. Well, let's just start doing some of the properties, and hopefully something nice will happen. That's what I do when I run into some big old problem like this, and I can't see through to the end. I just start doing what I can do. So, what can we do with this negative sign first off? What can I do with that negative sign? Put it to the front, right? Because sine is an odd function, right? Only cosine and his reciprocal are even, so negatives vanish. Negatives plugged in vanish. But for the other 4 trig functions, negatives plugged in go to the front, don't they? So it'll be negative sine of 67. I don't know if that's going to do anything nice. What am I going to do with a 427? Subtract 360 because that's more than a full circle. So is that 67? Yeah. You see that now? Plus tan. What's tan of 247? Oh, wait, no, I don't know. I still don't know. I don't know. Yeah, I do know. What are you going to do with tan of 247? Well, you could say it's, wait, hold on, before I write that way. Tan at 247, do you remember the period? You got to remember the period on these. What's the period of tangent and his reciprocal cotan? Yeah, they repeat more frequently. Every 180 degrees they repeat, whereas the period for sine and his reciprocal cosecant and cosine and his reciprocal secant is 360 full circle. So you want to remember that tangent is the special one when it comes to the period. Tangent repeats itself every 180 degrees. So in other words, the tangent, what that means is the tangent of, say, like 10 degrees is going to be exactly the same as the tangent of 190, because that's just 180 further. Does that make sense? That's what it means to have a cycle, right? Like we have a cycle of months. Not exactly this, but we do 30, 31, that kind of thing. But suppose it was perfectly, then we'd be repeating ourselves every 30 days, right? We'd be repeating whatever you wanted that. Well, that's what tangent does. He repeats himself. All his values, all his answers, just repeat every 180 degrees. Whereas sine and the rest of the other 4 trig functions, they repeat every 360, every full circle. The tangent repeats every half circle. He repeats all his values. Every half circle tangent and his reciprocal cotangent. Repeat every 180. So what then? Well, that means the tangent of 10 is the tangent of 190. Whatever, I don't know what either one of them is, but I know they're equal. Does that make sense? Because that's 180 further down the line. Right, this is 10 past 0, and this is 10 past 180. They're both 10 past the start, aren't they? So they're going to be the same value. Okay, so it's all about how far you are past the 180, right? Or some increment of 180. So, some multiple, I should say. Some multiple of 180. So anyway, long story short, subtract 180. You see why I'm able to do that? So this is the same as the tangent of, what is that? 67. What a surprise. 67. Whatever the tangent of 67 is, it's the same as the tangent of 247, because they're both 67 degrees past the start of the cycle. Yeah, that's a better way to say it, right? The tangent starts his cycle at 0, and then he restarts his cycle at 180, then he restarts at 360, then he restarts at whatever another 180 is, etc. Every 180, he restarts his cycle. So however far you are into his cycle, it's going to be the same value, whichever cycle you're in. Is that making sense? So 67 is 67 past the start of a cycle, and 247 is also 67 past the start of the cycle. So they're the same values. All right, I beat that horse to death. You got it. All right. So what is this? What's this? 0. Because tangent, this is sine over cosine, and this is negative. This is positive. Answer 0. Good. So you got to remember, tangent is so the tangent is special with his period, right? And remember, cosine is special because he's even. So if you want to memorize this as you go into calculus, all of you really have to remember, when it comes to periods, tangent is special, 180. When it comes to even odd, cosine is special, he's even. The rest are odd. So there's the properties. Two of them. It's a weird looking one. So cotan of theta plus the cotan of theta plus pi plus the cotan of theta plus 2 pi. Oh, and they're telling me up here, cotan of theta is 7. So this is 7. What do you think this is? Is it also 7? Yeah, it's also 7. Why? How do we know it's also 7? Because it's, what's pi? Yeah, we're all realizing, right, the pi's 180. Right? So remember, he repeats himself. So if you're at any angle theta, and then you're that angle past, right, because it's past pi, it just repeats the cycle every pi. So whatever this angle is, maybe it's 20 degrees or whatever. Now this is 20 past a pi. Well, that's 20 into the next cycle, because cotan and tan do a cycle every 180. So this is just 20 or whatever theta is into the next cycle. It's got to be the same value. And then this is into the second cycle or third cycle or whatever, 2 cycles down the road, right? This is also 7. 21 done. Makes sense? We're just making sure you know. Cotan has a cycle of 180 pi radians. All is well on that. Multiples of 180 are what? Or what? Okay, so cotan, they're asking me cotan of theta not defined. Okay, let's think about that. How can cotan not be defined? 0 in the denominator. How do we ever get anything not defined in math? Denominator 0. So what is cotan? What's the definition of cotan? Cosine over sine, right? So sine, when sine equals 0, it's going to be not defined. When the denominator is 0, it's not defined. So where does the sine of theta equal 0? That's the question, right? Because wherever the sine of theta is 0, then the denominator of cotan is going to be 0 and it's undefined, right? So where's sine of theta equals 0? Well, let's do the unit circle. What is sine? The x value or the y value? Sine is the y value, right? Sine is y value. So where is the y value 0? So right here. Is the y value of that dot 0? Is he at a height of 0? No. How about this one? No. Where? Where now? Do you see it? Boom and boom. Those 2 dots have a height of 0, don't they? Those are the only 2 dots on the unit circle that have a height of 0, huh? So what are those angles? 0, 180, whoops, 180. I'm an 80 problem. 180. And it'll be any multiples of 180, right? Because this is 360, that's 2 180s. And this is another 180, whatever. What's 360 and 180? It'd be 480, 540. 540, and on you go. You could just keep going 180, 180, 180, 180. Anytime you do 180, you go halfway around, you're in another dot where the sine, the height, the y value is 0. So the cotan will have a denominator 0 and be not defined. Make sense? We good with all that? So whenever they ask you about something being not defined, you think denominator 0. That'll be in calculus as well. So let me give you a domain and range of the functions. Is that the best way to do that? Yeah. Okay, let's talk about the basic sine and cosine graph. You know what the basic sine graph looks like, right? He starts here at the origin, he goes up and down and up and down. He just keeps going this way also forever. That's the sine. Put it up here, sine. And so his range is top to bottom. That's his range is vertical coverage. Remember how range is up and down coverage? What's his low and high for the sine? -1 to +1. That's his range. What's his That's a B. What's his domain? Domain is the width coverage. How far left, how far right? -infinity, +infinity. Goes forever. Sine does. Okay. So next, how about cosine? What's the difference between sine and cosine? Yeah, cosine just same thing, just starts high. Everything else is the same. Right? In the middle he starts high, in the middle he starts at 0. That's cosine. His domain's the same, his range is the same, right? Everything, domain and range are the same for sine and cosine, as you can see. Now, what about tangents? Anybody know about the graph of tangent? I don't have room here. I'll just put it where cosine was. So what does it look like? What is the graph of tangent? Anybody? It has vertical asymptotes at -π/2 and +π/2, and then cycles every pi. So this is going to be, let's see, move it there, 3π/2 because it's a full pi away. And then he does a snake. He kind of looks like x cubed. Remember x cubed? He just does a bunch of snakes forever. And he just keeps doing that and having a vertical asymptote every pi. If you just add or subtract pi, 180, he just keeps repeating the snake thing. So then, what is his domain and range? Let's think about what those might be. His range, which is the height. How high does he go? Positive infinity, negative infinity. So his range is up forever, down forever. What's his domain? His domain. Well, he goes to the right and the left forever, except he has π/2, so not π/2, not 3π/2, not minus π/2, not minus 3π/2, etc. So he has forever, but he has certain spots that he's undefined at. All right, and they're asking me about, what are they asking me about? Cotan. Cotan's basically the same thing, because he's just 1 over the tan. So it's going to be -infinity to +infinity. Right? Yeah, so it's B. It's all real numbers. So cotan is just like tan, it's just shifted. Yeah, so just treat cotan like. We're going to get more into it later. For now, let's just say it's basically the same thing. It's just shifted. What is he shifted? I think he's 0 to pi, isn't he? Yeah, because we just did where's cotan not defined? At 0 and pi, right? 0 and 180. Yeah. So he's saying he's just got his vertical at 0 and at pi. And he does his snake thing. And he might be upside down. I think he goes down instead of up, doesn't he? Let me think for a second. Is that true? I think it is true. Let me see. Because this one, you know how you can tell? Because this is between 0 and π/2, right? What does this one do between 0 and π/2? This one climbs. So cotan is upside down. Higher and higher values flip, become lower and lower values. Yeah. Right? Yeah. Yeah, that's right. Because, and then it's 0 at 0. Yeah, that's true. Yep. Anyway, there we go. So it's basically the same thing. He goes up forever, down forever. All real values. All right. Everybody got that down? That was a lot of writing. Everybody good that needs that? The properties. All right. Is the cosine function even, odd, or neither? Cosine? Even, right? Like we talked about. Is the graph of the cosine, so here's the graph. Where's the graph of the cosine start? Starts high instead of in the middle, right? So you tell me. Does that thing got any symmetry? With respect to what? Right. the y-axis. He's the same on the right and the left of the y-axis. The y-axis is a mirror for him. So he's y-axis symmetry. What about if they ask me about sine? You might get sine. Sine starts in the middle. It's the same as cosine, it's just shifted, right? Sine and cosine are the same graphs. They're just shifted a little bit. So sine starts in the middle. Does he have any symmetry? Is he, if you do the y-axis, is he exactly the same to the right and the left of the y-axis? No, he's upside down, right? He's going up to the right and down to the left. That's not the same, right? Whereas this guy's, ditto. Right and left, it's ditto, for the cosine. So the sine does not have y-axis symmetry, but what symmetry does he have? Origin symmetry. Remember, every odd function has origin symmetry? Wait, is that true? Yeah, that's true. Anyway, he's odd, so yeah, he has origin. Remember origin symmetry? That's if you rotate it 2 quadrants. If you take this piece and go boom, boom, 2 quadrants, there it is. 180-degree flip. Right? All right. I can talk. All right. So f of x is cotan of x. F of a is 19. F of a. So that means cotan of a is 19, right? See what they're saying? Because f of x is cotan of x, so if you plug in a, the a gets plugged in there too. So f of a, cotan of a, is 19 is what they're saying, right? Okay? So now they're saying, what's f of negative a? So if the cotan of a is 19, what's the cotan of negative a? Well, we got to go back to those negative plug-in rules. So if you plug a negative into cotangent, what does that mean? Does it come to the front, or does it just vanish? Yeah, which ones vanish? Cosine and his reciprocal secant. So the negative comes to the front. It's negative 19. That's the answer to part A. And part B says, what's f of a plus f of a plus pi? Pi is 180, right? Plus f. This is the same thing we did before, huh? 2 pi. It's just going to be 19, 19, 19, because cotangent has a period of pi. So if we just keep adding pi, nothing's going to change. 19, 19, 19, 20, 57? 30, yeah, 57. Is that good? There's the trig properties. You've seen those before? Little refresher. Maybe they're a little more solid than they were before. I want to go on to 6.4, if you're okay with that. 7.1 is we'll talk about inverses. Remember the inverse function. It's important to do that before you guys go into calculus. Guys and gals go into calculus, get inverse functions looked at again. And then the last section will be putting them in triangles and that kind of stuff, real life applications. Okay, so for what numbers between negative pi and pi is the graph of cosine decreasing? So where's the graph of cosine decreasing? Suppose you're on a roller coaster. This is a roller coaster. We're riding the roller coaster. You impressed with my graphical skills? Right there, we're going up. Up, up, up. You get to the tip top, everybody screams, you're going down, right? That's decreasing right there, isn't it? From here to here. Here to here. This is the decreasing section, huh? So from 0 to pi. From 0 to pi. Did I get that almost? Yeah, 0 to pi. From 0 to pi. This section is D. They want it on the x-axis, right? It's x between 0 and pi. Good. So that's E. So they're saying for what x values, when is the sine of x 1? Right, this is the y value. They're saying, where's the height 1? Right here. Right? At x is pi over 2. At x is pi over 2, the sine comes out of height of 1, doesn't it? Good? On that. Okay, y equals 9 cosine x. That right there is called the amplitude. That means if you were to graph this cosine function, instead of starting up here at 1 like they normally do, going down and up and down and up like that, like a normal cosine, what is that 9 going to do in front? Yeah, it just vertically stretches the thing. Well, we know that. That's a y effector. Remember back early in the course, we talked about numbers multiplying the front, right? Because he's not in there with x. He's not an x agent, right? He's not in there with x. He is a y effector. So he'll make the thing start way up at 9 and go way down to -9. It'll go, you like that. Right, da-da-da. That's what it'll do. So that amplitude is how high and how low the graph goes, 9. And then they also want, what else do they want? Oh, period. What's the period of cosine? Yeah, it's 2 pi, unless they mess with the x stuff. If they mess with the x stuff, then that'll change it. I'll show you that in a minute when they do mess with it. But for now, it's just 2 pi. That good to there? Questions? Okay, so y equals 4 sine pi x. Now that 4 is the amplitude. No big challenge there. But now, what's the period? Well, the period, let me give you a formula in general. Anybody know it? Trying to remember it, huh? Isn't it 2 pi over omega?
Yeah.
Or omega over 2 pi? Let me think for a minute. Because that'd be pi, so it'd be... So the period. So I would be saying, and omega, what is omega? Omega, or if you want to call it W, they use the Greek, I'm saying omega because it's the Greek W, but whatever, call it W if you want. And all they mean by it is they mean whatever's next to the x. That's what they mean by that W. So when you have the sine of WX, the period will be 2 pi over that thing next to x. Great and important formula if I've got it right. I think it's right. Let me double check. So that'd be 2 pi over pi. That'd be the period is 2. Does that thing really have a period of 2? Yeah, it does. Yeah, yep, that's right. Yeah, so that's, really important, very, very useful in this section. Write that down in your, well, it's not on the next test, but the final, beyond the final, 2 pi over W, if you want to call it that, omega. It's the period. So it's 2 pi over whatever's next to the x. And that works for sine, cosine, either one, comes up a lot. So 2 pi over whatever's next to x. That'll tell you the period. The period on this one's just 2. The period, if you want a little more feel of it, how do I know that's right? Because it is always best to understand instead of memorize. You see, I can test my memory, which is shaky, by understanding, which is always more reliable if you understand. So I'm saying I can tell that's right because a period is how far you have to plug in x to make it repeat. That's what a period means, right? So in other words, what x values along the x-axis make it repeat a full cycle? Well, it's true that when x gets to 2, because what happens when you plug in 2 for x there? What is that the sign of? Pi x, pi 2, when you plug in 2? 2 pi. It's hit 2 pi by that time. Which, that means it's going to repeat. I know sine repeats every 2 pi. So when x hits 2, it's repeat time. So I'm like, yeah, that's right. That is the period. 2. So anyway, you don't have to know that, but maybe just keep reminding you. The more you can think it deeper. Okay, so amplitude, that's easy. Amplitude's right here, right? Whoops, right here. So amplitude 5/7, no big deal. And that, even if that's negative, by the way, even if negative in front, amplitude equals the positive version. For whatever reason, they just defined amplitude as give me only the positive answer. I don't care if you give me negative on a test, but Math Excel will hassle you. So I'm saying even if they made that negative 5/7, you would say the amplitude is positive 5/7 because they just mean the gap. I don't know how to say it. The distance from middle to top is what they mean. And whenever you talk distance, you don't give a negative, right? So that's whatever. That's their weird thing. So what's the period, though? Let's do the period. It's 2 pi over omega. Omega meaning whatever's next to x. What's next to x? negative 2 pi over 7. Does that make sense? And what do you do with a fraction on the bottom of a fraction? Give it a flip. So it's 2 pi times 7 over negative 2 pi. 2 pi's cancel. The negative is still there, though. Negative 7. And that the negative does matter there. Wait, is that true? I don't know. On a test, I don't care. 7, negative 7, whatever. Let's go type it in and see. Let's be clear. They only want, cross that out, positive 7. So they only want the positive version for period and amplitude. On a test, I don't care. Because you're just saying how often it repeats. So whatever. It's just a language thing. It really doesn't matter. The concept's the same. That kind of stuff is not interesting to me. So, all right, here we go. Now, match the function. Match the function. Which one of those is negative 2 cosine of a half x? It's not going to be multiple choice on the test. Not going to be multiple choice. I'll ask you just to draw it straight. So pretend these aren't even here. I'll just say, hey, graph me that. And I'll say, show me one cycle. Show me between 0 and 2 pi. So that's going to take some practice, huh? So let's do it. So how do you do it? How do you graph? Well, the first thing is to get the period. What's the period? 2 pi over omega. So 2 pi over a half. Flip it up. 2 pi times 2 over 1. 4 pi. We good? So 4 pi is the period. Now, what does that mean that's the period? That means if you go to graph this thing, I wish these things weren't in the way. When you go to graph the thing, between 0 and 4 pi, the graph will happen. One cycle. And then it'll repeat another cycle after that. In fact, you know what? I better make that shorter. Why don't I put 4 pi about right here? And then this will be 8 pi and etc. But anyway, I'm just focused on 0 to 4 pi, and then after that it just keeps repeating the same thing. Does that make sense? So here's how we do this. You kind of get a chunk, a box for one cycle by finding the period, 4 pi. So between 0 and 4 pi, it's going to do its whole cycle. Now, we got to be clear, this is cosine. What does cosine do? What does the normal, regular cosine do? He starts high, goes low, comes back high. That's one cycle. And then he repeats that again. Another cycle. You see that? Whereas sine, that's what cosine does. If we had sine, we don't, but in a minute we will. Sine starts at 0, goes high and back to 0. And then he repeats that back to 0. So you've got to be clear on that in your mind. Cosine starts high, ends high every cycle. Sine starts at 0, ends at 0 every cycle. Right? That's the difference. They're just shifted 90 degrees from each other. Quarter cycle. So we're dealing with cosine. So we're going to start high, end high. So I'm going to do this wrong at first, and then I'll correct it. So I'm thinking, not quite right, that it should start high and end high in the one cycle. Remember, one cycle is 0 to 4 pi. Okay? So I'm thinking he should go like this. But that's not quite right. There's one other mistake. What's that doing? Negative 2. What does negative do to any graph on the y effector? Negative on the y. That's a y effect. It's not in the x zone. That's in the front with the y. Upside down, right? That negative is going to flip it upside down. So instead of starting high, ending high, that's going to start low, end low, and go up in between, like that. And where does it start? Negative 2, and it goes up to positive 2. Does that make sense? And then we just repeat that. So then I can just repeat it again, like that, and repeat it again and again and again and again. Does that make sense on that? So it goes down to negative 2, that amplitude, and always up to positive 2. So there we go. There's the graph. That's not too bad, right? For graphing. So which one's right? Oh, is it A? Is it this one? Yeah, it finishes it by 4 pi, doesn't it? There's between 0 and 4 pi. Good. Can you do that without multiple choice on the test? So just find the period, 0 and 4 pi, and then realize cosine normally starts high, ends high, but the negative makes him start low, end low. Start low, end low. All right. Let's do All right, let me give you a try. So first thing, find the period. Don't worry about those multiple choice options. They won't be there on the test. Just start cranking out the period. Pi over omega. Pi over 1/3. Flip up the 1/3. 6 pi. So the period 6 pi, which means he does his thing between 0 and 6 pi. He does one cycle, and then he'll just keep repeating that. 12 pi, a whole nother cycle will happen, and on you go. Right? So he's going to do his whole cycle between 0 and 6 pi. And he's, well, I'm going too fast. Let me let you think now. He's a sine graph. He's not a cosine. So when sine does his thing, how does he start? How does he end? So cosine starts high, ends high. Right? Cosine starts high, ends high, but sine starts at 0, ends at 0. Begins by going high. After starting at 0, it goes high, then goes low, then back to 0. But he's got a negative in front of him. So he's still going to start at 0, but instead of then heading high because of the -3, flip him upside down, he's going to go like that, isn't he? He's going to go low. He's going to do it all by 6 pi. He's going to go low, back up, high, boom. And how far is that low? -3. How far is that high? +3. Does that make sense? And it'll just keep repeating that. Everybody good with that? One cycle between 0 and 6 pi. Starts at 0, ends at 0, but goes low first because of the -3. He's upside down. All right, which graph is that one? It's this one, yeah. Yep, by 6 pi. He started at 0. Back at 6 pi, he's down. He's done. He went down first. That's correct. Between 0 and 6 pi, he does one cycle. Is that good? So we can do questions on that. Can we